Hi students, in this week's video, we're going to do a quick revision on prime numbers, prime factorization, and highest common factor and the lowest common multiple. This video is useful if you are doing some revisions for your year-end examination. So what is the definition of a prime number? Yes, a prime number is a whole number that has exactly two different factors. The keyword is the word different, one and itself. Right, so therefore, if you look at the screen, 1 it's not considered a prime number because 1 has only have two factors, similar factors, 1 and itself, which is 1. Right, so therefore 1 is not considered as a prime number. Right, neither is it a composite. Likewise for the number 0. Right, so a composite number will be a whole number that has more than two different factors. Let's do some examples. Let's look at the number 13. So 13 is equals to 13 times 1, and therefore it has two different factors, 1 and 13. Let's look at the number 20. We can write 20 as 20 times 1. However, 20 is also 2 times 10. 20 is also 4 times 5. So in this case here, 20 has factor 1, 2, 4, 5, and 10 and 20. 1, 2, 4, 5, 10, and 20. Yes. So therefore, 20 is not a prime number, but 13 is a prime number. And we can also call 20 as a composite number because it has more than two different factors. So examples of other prime numbers are 2, 5, 7, 11, 13, 17, 19, 23, 29, and so on. Right, sometimes in the exam, you may be asked to determine if a number given is a prime or a composite number. Right, so how are you going to test if the number given is a prime or composite number? There's actually a way to do it. Yes, so step 1 is to find the square root of the number b. Supposing you're given a number, let's call it b. Right, so we use the calculator to find the square root of this number b. And supposing that the answer you get after you square root this number b, let's call the number a. So we find all the prime numbers that's less than or equal than the number a. And step 3 is to divide b with all the prime numbers. If b is divisible by any of the prime numbers that's less than or equal than a, then b is a prime number. So let's look at an example. Explain whether 997 is a prime or a composite. Right. So what do we do? Yes, step 1, let's find the square root of 997, which is approximately 31.6. So hence the largest prime number is 31. So all the prime numbers that is less than 31 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. And basically, you can just use your calculator, right? Take a 997 and try to divide by 2, divide by 3. Basically, divide by all the prime numbers there, right? And if it's not divisible by any of them, then we can conclude that 997 is a prime number. So this is one way that you can explain whether 997 is a prime or composite. Right, let's look at a possible exam questions. Right, so if you're given P and Q such that they are whole numbers, and P times Q equals to 31, you're asked to find the values of P plus Q. Right, so actually 31 is a prime number. But supposing if we do not know 31 is a prime number, we can use the test that we have learned earlier on, right, to justify that 31 is a prime number. So do you remember the steps that involved? Yes, first of all, we square root 31, and you'll get 5.6. So therefore, the largest prime number that's less than or equal than square root 31 is 7. So all the prime numbers that are before 7 will be 2, 3, 5, and 7 itself. So if you take 31 and try to divide it by 2, by 3, by 5, by 7, you'll see that it is not divisible at all by any of these numbers listed. So since 31 is not divisible by any of the prime numbers listed, 31 is a prime number, and as such, it has only two different factors, one at itself. So therefore, 31 is equals to 1 times 31. So in this case here, we can say that P is equals to 1, Q is equals to 31. Sorry, P is equals to 1, yes, Q equals to 31. So therefore, P plus Q will just be 1 plus 31 equals to 32. Right, let's look at another possible exam questions. Supposing you're given that n is the whole number such that n times bracket n plus 28 is a prime number, find the prime number. And then you have to explain your answer. Alright, so let's look at the definitions of a prime number. Yes, a prime number is a whole number that is exactly two different factors, one and itself. So for example, if a is a prime number, then a is equals to 1 times a. And a must be different from 1, so it's two different factors. So since n times bracket n plus 28 is a prime number, then the two factors are n and n plus 28. And since one of the factors has to be the number 1, we'll let n equals to 1. And hence n plus 28 is equals to 29. Because 1 plus 28 is 29. Therefore, the prime number is 1 times 29 gives you 29. Right, but can you let n plus 28 equals to 1? If you let n plus 28 equals to 1, then the other number will be negative 27. And negative 27 is not a prime number. Right, 27, it's actually equals to 3 times 9. Right, so therefore you can't let n plus 28 equals to 1. Right, so the next thing we're going to look at is prime factorization. This prime factorization is a very important concept involving prime factors. So what exactly is prime factorization? It's actually the process of expressing a number as a product of its prime factors. So let's look at some example. Right, if you look at 24 is equals to 2 times 2 times 2 times 3. So if you look at all the factors here, they are all prime numbers. 2 it's a prime number, 3 is also a prime number. However, let's look at another number, 104. So 104 is equals to 2 times 2 times 2 times 13. So they're all prime numbers. 13 is a prime number, 2 is a prime number. Okay, let's look at what is not prime factorization. If you look at the number 24 itself, you can actually write it as 8 times 3. However, 8 is not a prime number. 8 is a factor of 24, but it is not a prime factor. So therefore, 8 times 3, it's not prime factorization. Let's look at another number that says, yes, similar, using the same number 24, it can be written as 4 times 2 times 3. Right. However, 4 here, it's a factor, but it is not a prime factor. Right, likewise for 104, it can be expressed as 2 times 2, which 2 is a prime factor, however 26 is not. So if you look at the number 1024, it can be written as 2 times 2 times 2 times 2 times 2, so on and so forth. 10 of 2s, right? And 2 is a prime number. So we can actually stack all this number up into 2 to the power of 10. So 2 to the power of 10, there's a special name to it. If you express a number as a base and a power, a base or index, okay, you can call the power index a to the power of n, right? The format is called index notation. Right, so supposing if you have 2 times 2 times 3 times 7, right? So we can stack the 2 up to be 2 squared times 3 times 7, right? So therefore 2 times 2 to the power of 2 times 3 times 7 is expressed as index notation. Right, let's look at practice question 1. There are two questions that we need to solve. The first one is to find the prime factorizations of 1, 2, 6, leaving an answer in index notation. The second one is to express 792 as a product of its prime factors. So there are two ways of finding the prime factors of a certain number. The first method is called the tree method. Right, basically, you start off with 126, and then you take 126 to find the smallest possible prime factors, which in this case here is 2, right? So 126 is actually equals to 2 times 63, right? So it's a 3 method, so there are the branches into 3, right? So you start off with having 2 branches first. So one of them is the factor 2, and the other one is 63, right? And because 2 is already a primed factor, right? So we will just continue with this the same number throughout. However, 63 we can further divide it into 3 times 21. So what this method is all about is to break down the number into prime factors. So 3 times 21 will give you 63, and 2 and 3 are already prime factors, right? So we will just continue to, right? So because 2 and 3 are already prime factors, so we just continue the branch. However, the number 27 again can be broken down into 3 times 7. Alright, so now we look at the final answer. You'll see that the number 2, 3, and 7, they're all prime numbers. So therefore, the prime factorizations of 126 will be 2 times 3 squared times 7. Alright, you have to write it in index notation. Therefore, you cannot write it as 2 times 3 times 3 times 7. Right, if you write your answer as 2 times 3 times 3 times 7, okay, you'll be marked wrong because you're asked to express it in index notation. You have to stack this 3 times 3 to become 3 to the power of 2. Alright, let's look at part 2. So for questions, part 2 of questions 2, I'm going to use another method that's called the ladder method. So basically this is how it looks like. Alright, so it's like something like looks like a ladder. Okay, as we progresses, you'll see that it kind of looks like a ladder. So we start with 792. So as 126. Okay, right. So we start off with the smallest possible prime factor, that is 2. So 126 divided by 2 will be 63. And then of course 63 it's not divisible by 2. However, it is divisible by 3. So 63 divided by 3 will give you 21. Again, you can divide by 3 to get 7. And then 7, of course, divided by 7 to gives you 1. Right, so you have to continue to do until the remainder here, it's 1. Right, so therefore the prime factorization of 126, you'll get the same answer, which is 2 times 3 squared times 7. Okay. Right, let's look at question 2. You can use the tree method or the ladder method. Alright, so I'll be using the ladder method. So we start with 792. So the smallest possible factors will be prime factors will be 2. So you can just use a calculator to help you. Take 792 divide by 2, and that gives you 396. Right, so you can continue to let it divide by 2. However, I think 3 is a better choice. So that will gives you 132, and then 3 again. That gives you 44. Alright, then you can't divide by 3 anymore, so that's divide by 2, and then 11, and then 11 divided by 11 gives you 1. Okay, so therefore the prime factorization of 792 will be 2, 1, 2, 3, so to the power of 3 times 3 to the power of 2 times 11. Okay, so that's how you do it. Alright, so let's look at another question. Express 2021 is a product of its prime factors. Okay, so this one is slightly, this one is much harder, right? Because you will see that if you take 2021, It is not divisible by 2, not divisible by 3, not divisible by 5, by 7, right? Basically, you have to try many prime factors. So one way to do it, it's what we have learned earlier on, right? We just find the square root of 2021, right? And then we try to divide it by all the prime factors, prime numbers that is before that exist before the square root of 2021. So if you were to use a calculator, square root of 2021 will gives you 44.9. So let's try to divide 2021, right, with all the prime factors, prime numbers that is before 45. So 2021, if you divide by 45, of course you won't get a whole number, right? So 2021 divided by 44, again it's not 2021 divided by 43. Yes, you will get 47. And basically 47, it's also a prime number, right? So the prime factors for 2021 are just 43 and 47. All right, let's look at part 2. All right, so part 2, so 2021 can be written as 43 times 47, but it can also be written as 1 times 2021. All right, and since we are asked to write down the possible pairs such that the number A must be less than the number B, right? So one possible pairs will be 43, 47 and 1, 2021. Right, sometimes prime factorization can be used to find the cube root or a square root of a number, right? So for question 1, we are asked to find the cube root of 2744 using prime factorization. So we need to express 2744 as a product of its prime factors. So we should use the ladder method to do it. So 2744 is divisible by 2. That gives you 1372. Divisible by 2 again to give you 686. Divisible by 2 to get 343. So 343 is divisible by prime number 7. Gives you 49. Right. So therefore, the prime factorizations of 2744 will be 2 cubed times 7 cubed. And so the cube root of 2 cube will be 2, and the cube root of 7 cube will be 7. So that gives you 14. So that's how you do question 1. So for question 2, right, you're given already that the prime factorizations of 9261 is 3 cube times 7 cube. So therefore, the cube root of 3 cube will be 3. The cube root of 7 cube will be 7. So that gives you 21. So this is relatively easy. Right, so let's look at a N-level questions. This one is the year 2014. Right, you're supposed to write 156 as a product of its prime factors. That's easy. You can either use the tree method or the ladder method. Alright, so 156, we start off with the smallest prime number, which is 2. Oh, I start off with 3, sorry. You can also start off with 2, right? Because 156 is also divisible by 2. Never mind. So 52 divide by 2. Now we have to try to divide it by 2 to get 26, and then by 2 again, get 13. So 13, it's, yep. Alright, so the prime factors of 156 will be 3, 2 squared first, right? The smallest prime number first, which is 2 squared times 3 times 13. Alright, let's look at B. Okay, find the highest common factor of 156 and 390. Now we already have the prime factorization for 156, so we're going to do the same for 390 using the ladder method. Okay, so the prime factorization for 390 will be 2 times 3 times 5 times 13. Right, so there's a way of finding the highest common factor of these two numbers. Basically, we need to arrange it. Okay, arrange it properly. Right, put all the 2s and 3s and 13s in blocks. This is called blocks. So you see that for the number 156, I don't have the number 5. So if there's no number 5, I replace it with the number 1. Alright, so from there, from these two prime factorization, I need to find the highest common factor. So the highest common factors of 2 squared and 2 will be 2. And the highest common factor for 3 and 3 basically will just be 3. So to highest common factors, you just take the smallest of the two numbers there. Like 1 and 5, you just take 1. And of course, if it's 13 and 13, then you have to take the number 13. If it's 2 squared and 2, of course, you take the smaller number, which is 2. Because we're talking about factor, right? So therefore, the highest common factor for 1, 5, 6, and 390 will be 2 times 3 times 13. And that gives you 78. Right, let's look at another n-level questions. Here you're given the prime factorizations of p to be 2 cubed times 3 to the power 4 times 5, and the prime factorizations for q to be 2 times 3 to the power a times 5 to the power 2, where a is an integer greater than 4. So we asked to find the lowest common multiple of p and q. Right, so let's arrange number accordingly. So from these two prime factorization, we'll find the bigger number of the two. So between 2 cube and 2, we'll take 2 cube, and 3 to the power 4 and 3 to the power a, we'll take 3 to the power a because a is an integer greater than 4. And between 5 and 5 squared, we'll take 5 squared. So therefore, the LCM of p and q will be 2 cubed times 3 to the power a times 5 squared. So let's look at part B. So for part B, we're asked to find the largest perfect square that is a factor of both p and q. Right, so a perfect square is a number that can be expressed as something to the power of 2. Right, so for example, 4 squared, this is a perfect square. 8 squared is a perfect square. Right. Alright, so if you look at the first one here, the prime factorization for p, we can break up 2 cubed as 2 squared times 2. So 2 squared is a perfect square, but 2 is not. We can break up 3 to the power 4 as 3 squared times 3 squared. So this is a perfect square, this is a perfect square. But 5 is not, right? So, but we need to find the largest perfect square that is a factor of both p and q. That means it must happen in p, it must also happen in q. Right, so we are told that a is an integer greater than 4. So in other words, it's possible to have this one here, we can rewrite it as 2 times 3 to the power of 2 times another 3 to the power of 2. It's an integer greater than 4, so a can be 5, right? A can be 6 or 7, etc. Right, so the minimum value it can have is 3 to the power of 2 times 3 to the power of 2, and then times 5 to the power of 2. Okay, so if you do a comparison, right, it must be a perfect square that's a factor of both p and q. So if I'm going to choose 2 squared from p, I need to have 2 squared from q, which I don't have it at all. Okay, so this is out. I have 2 from p, 2 from q, but 2, it's not a perfect square. So this is out also. Okay, and then let's look at 5 also. 5 is not a perfect square, so definitely it's out. So I'm only left with this. Right, so therefore the largest perfect square will be 3 squared times 3 squared, which gives you 81. Right, let's look at the O-level questions. So the O-level questions, you'll see that it's slightly harder than the N-level. It involves more steps. So let's look at part I. Part I, you asked to write 144 as a product of its prime factors. So that's similar to the N-level questions. We can just use the tree method or the ladder method to find the prime factors for 144. Right, so we can take 144 to divide by 2 to get 72. divide by 2 again to get 36, divide by 2 to get 18, 2 to get 9, divide by 3. Right, so the prime factorizations for 144 will be 2 to the power 4 times 3 squared. Alright, so you're also told that you have a number 12 and it can be written expressed as 2 squared times 3. Okay, so for part 2, we are told that you're supposed to find two numbers. These two numbers must be greater than 20, such that the highest common factor of these two numbers is 12, and then the lowest common multiple of these two numbers is 144. Right, so how do we find these two numbers? So we will have to work backwards. That means we have to use the highest common factor and the lowest common multiple, and then we have to work backwards to find the two numbers. So we start off by writing down your HCF and LCM. Okay, so one of the number definitely has to be 2 to the power 4, because then that will explain how I get 2 to the power 4, right? One of them must be 2 to the power 4. And the other one, of course, must be 2 to the power 2. So we know that the first number will have the number 2 to the power 4, and the second number will have the number 2 to the power 2. Okay, so the first number will have 2 to the power 2, second one will have 2 to the power 4. Okay, then how do you explain? Right. Yeah, so same explanation as what I've done earlier on. Okay, the one of them must have 3 to the power of 2, one of them must have 3. Okay, I can have 2 to the power of 2 times 3, right? And 2 to the power of 4 times 3 squared. Okay, however, the number must be greater than 2. So if I have this combination, you see that 2 squared times 3, that will give me 12, and 12 is a number that is less than 20. We want a number that's greater than 20, so this combination, it's not suitable. Although 2 to the power of 4 times 3 to the power of 2 is a number greater than 20, but this one here did not satisfy the criteria given. Okay, so this is not a good combination, so therefore the correct one will be 2 to the power of 2 times 3 to the power of 2, which is 36, and 2 to the power of 4 times 3 will be 48. So the O-level questions is slightly more tricky than the N-level questions because it involves more thinking. Alright, so let's look at another questions. Here in this case here, we're given the prime factors for 784 to be 2 to the power of 4 times 7 to the power of 2, and we're going to divide this number with P over Q, such that ultimately my final answer has to be a perfect cube. So what is a perfect cube? Perfect cube, it's a number that can be expressed as something to the power of 3, right? So it could be 2 cube, that is a perfect cube, or 3 cube, that's a perfect cube. Alright, so we're going to change the division sign to the multiplication, and then you have to flip your fraction here, and then the next thing is that I'm going to write it as a fraction. Alright, so to get the perfect cube, okay, let's see what happened. Right, so to get the perfect cube, you see that I have 7 to the power of 2. So I need to multiply with another 7 here, so that this will give me 7 to the power of 3, which is a perfect cube, right? And if I divide, okay, let's now look at 2 to the power of 4. If I divide this 2 to the power of 4 with the number 2, this one will give me 2 to the power of 3, right? Because what I'm interested in is finally I need to have something to the power of 3, 2 to the power of 3, and then 7 to the power of 3. Okay. So if we compare these two, the second and the third steps, right, you see that Q is actually 7 and P is actually 2. Okay, let's look at the second O-level questions. It's similar to the one we've done earlier. part A is to express 450 as a product of its prime factors, so we can use ladder method to do it. If you do not want to start with 5, you can also try dividing 450 with 2, then progresses to 3 and then to 5. So therefore 450 can be expressed as 2 times 3 squared times 5 squared. For part B, the method is the same as what we've done earlier, except that the two numbers here must be smaller than 100. Okay, let's write down the LCM and the HCF first. Okay, so if you look at the HCF, I don't have 2 as a prime factors, therefore I replace it with 1. By replacing with 1, I do not change the value of the HCF. I still get 15, which is what is indicated here. Okay, so the explanation is the same as what we have earlier on. One of the number must have a 2 and the other number must have a 1 to account for the LCM and the HCF. Likewise, one of them must have 3 squared, one must have 3, and one must have 5 squared, the other one must have 5. So it's just rearranging it such that both number must be less than 100. So one possibility will be okay, you can have other possibility like what I've mentioned earlier on. You can have, instead of having this 2, you can have it 1, and instead of having this 3 squared is 3, and instead of having 5 is 5 squared. However, that will gives you 1 times 3 times 5 squared. That will be 75. Oh, which is the same as what I've got here. Okay, right. So if we have chosen 3 as the first number, then the second number must have a 3 squared to account for your LCM 3 squared here. Yeah, so no matter how you do, you will just get these two combinations only. Right, so therefore the two numbers will be 75 and 90. Right, so this complete the whole video on the concepts of prime number, prime factorization, finding HCF and LCM. Right, okay.